Hello and welcome back. We've spent the last several videos preparing for what we're going to do today, our first unit conversion word problem. We started at the lake learning about the fundamental quantities of time, length, mass, and temperature. Then in the lab, we learned about the imperial and metric systems and how we can go between them through a unit conversion. Remember, a unit conversion uses a conversion factor, an equal ratio of units used to change from one unit to a different unit while maintaining the original measurement. We can only convert within the same fundamental quantity. No going between time and mass or temperature and length. Stick with what you're given. We saw unit conversions in real life by looking at equivalent marks of inches and centimeters, and we also got to get more familiar with the metric system, which we don't use as much when we made the chocolate chip cookies. Instead, we got to see the imperial units, such as pounds, when we took a look at our stick of butter, which was 1/4 pound. This helped us to develop a better sense of unit intuition, which will help us as we work our word problems to make sure our answers are reasonable.
So let's begin with our problem setup. We're trying to get from one unit to the other. Our starting unit is what we're given. The end unit is what the unit we want it to be in when we finish the problem. Right here in the middle is our conversion factor. This is what helps us get from the start unit to the end unit. We multiply the start unit by this conversion factor in order to get it in the same units as the end unit. Okay, so let's start with an example problem from when we were at the lake. Let's say we pick up a branch that's 37 inches long. That'll be our starting unit. So let's write that right over here. 37 inches. All right, now we're going to multiply that by our conversion factor. So we've got to change it from inches, that's our starting unit again, to centimeters. There are 2.5 centimeters in 1 inch. 1 inch and 2.5 centimeters are equal to each other, so it's like we're multiplying 37 inches by 1. And that will give us our end unit. So 37 times 2.5 centimeters. That gives us 92.5 centimeters. Let's try another problem. Let's say we go to the lake and pick up a rock that's about 910 grams in mass. Now we have a 15-gallon bucket. In order to fill that bucket, how many rocks can we put in that bucket? Now we're assuming that each of those rocks is 910 grams. We'll just assume all of the rocks are like that. So let's set up a conversion. Our starting unit is 910 grams per rock. We're going to multiply that by a conversion factor of 454 grams for 1 pound. Multiplying that will give us our end unit, which is pounds. So let's divide 910 by 454. That's approximately 2 pounds for 910 grams. Now if we have a 15-gallon bucket, 15-pound bucket, let's see how many 2-pound rocks we can put in there. Let's divide 15 by 2 pounds per rock. And that gives us 7.5 rocks. Now, obviously we can't put 7.5 rocks in the bucket unless we have something to chop a rock in half. And we can't put 8 rocks, we can't round it up, because if we did, then we would have 16 pounds in the bucket, which is too much. So we'll have to round down and only put 7 rocks in. That'll be about 14 pounds. So there's 1 pound that we couldn't use, but that's okay. As long as we're under the maximum of 15 and we've put in the maximum amount of rocks that we can. Let's take a look at volume next. In this example, let's say we were out at the Black Warrior River. Now, Dr. Terry's lab involves filtering water from this river through biofilters. So one of her lab assistants grabs 20 gallons of river water to run through the biofilters, but our tests only require 4 milliliters for each test. So let's do a little conversion to figure out how many of those samples can be run from the 20 gallons of water. Let's start with our start unit, 20 gallons. And we're going to multiply that by our conversion factor. That's 3.78 liters, because liters is our end unit, over 1 gallon. And that should give us our end units of liters. So 20 gallons times 3.78 liters is 75.6 liters. Now, once we've got it into liters, we need to convert it into milliliters. The metric system is nice because everything is in multiples of 10. So a milliliter is 1/1000th of a liter. So let's do that conversion. We have 75.6 liters times a conversion factor of 1,000 milliliters per 1 liter. And that gives us 75,600 milliliters. Now that we have that number, that's how much is in 20 gallons. So let's take our volume of the 20-gallon bucket in milliliters, which is 75,600 milliliters, and divide that by the number of milliliters for each test, which is 4 milliliters per test. When we divide that, it gives us 18,900 tests. That's the number of tests we can do with 20 gallons of water.
Action.
In this problem, we're going to be looking at cookies, like the ones we baked in the last lesson. So in this time, we have a 77 centimeter pan. That's the length of it. So this length at the top of the pan, we'll say is 77 centimeters. Now we have one 5-inch diameter cookie right up here in the corner. That's 5 inches. Now the rest of these cookies will be smaller 3-inch cookies. And we're trying to figure out how many 3-inch cookies can we fit on that pan, along with that 5-inch cookie. So let's set this up starting with our 77 centimeters. That's our starting unit. We're going to convert that into inches. Now our conversion factors for centimeters to inches says that there are 2.54 centimeters in 1 inch. Let's try a problem with cookies next, like the cookies we baked in the last lesson. In this problem, we have a pan that measures 77 centimeters across the top. So we'll say this length right here is 77 centimeters. Now we have one 5-inch cookie in the corner of that pan. That's right there. We're trying to figure out, after that 5-inch cookie, how many 3-inch diameter cookies can we fit in along that edge next to it. So let's start by converting 77 centimeters into inches. 77 centimeters, and our end unit will be inches. So the conversion factor for centimeters to inches is 2.54 centimeters for every 1 inch. And when we divide 77 by 2.54, we get 30.31 inches. Now we're not done yet. First, from that length, we have to subtract our 5-inch cookie. So 30.31 inches minus 5 inches equals 25.31 inches. Now that we have our new length, we have to figure out how many 3-inch cookies will fit in that length. So let's divide it by 3 inches. 25.31 inches divided by 3 inches per cookie. And when we divide that, we get 8.43 cookies. Now we want to know, after those 8 cookies, we still have 0.43 cookies left over. How much distance is that in both inches and centimeters? So if a cookie is 3 inches long, let's take that remainder and multiply it by 3 inches. So 0.43 cookies. And we'll treat this as a conversion factor in itself. We'll say there are 3 inches for 1 cookie. When we multiply that, we should get 1.29 inches, or approximately 1.3 inches. Now let's convert that remainder to centimeters to figure out what that distance would be in centimeters. So 1.29 inches times our conversion factor equals our centimeters unit. So we'll put our end unit on top, 2.54 centimeters, and our start unit on bottom, 1 inch. 1.29, or approximately 1.3, times 2.54 is approximately 3.3 centimeters. So these two are the remainders to our problem, and we can fit approximately 8 whole cookies on the sheet. Thanks. Thanks for watching our unit conversion section. Stay tuned for more videos.